All right, hello once again. This is Jeff Scott of Rankin Technical College, and I've been going over the PowerPoint presentations for Murock's Android Programming 2nd Edition by Joel Murock as part of the AWD1112 or 1112 Java programming class. And so far, I have gone through the first 9 chapters of the book. Chapter 1, an introduction to Android in Android Studio, where we talked about an overview and we looked quickly at Android Studio. Chapter 2, where we went through the tip calculator app, pretty much the completed app, and we looked at how the user interface was built. Chapter 3, when we learned how to write the Java code that went along with this. Chapter 4, where we talked about testing, debugging. We went through the debugger, we went through how to create an emulator, etc. Chapter 5, where we went over the major widgets or controls that you have in Android. We also talked about layouts, all right, and those, as you can see with those widgets, we talked about editable text views, all right, checkboxes, radio buttons, spinners, seek bars, images. Then we went to Chapter 6 and we talked about event handling. We distinguished between high-level events and low-level events, talked about 4 techniques for handling events, and then looked at some of the events in detail. Finally, we looked at how they apply to the tip calculator. Then we went over Chapter 7, 8, and 9. And as I mentioned, I don't even know if I'm going to go over these in class. All right? Just because of time constraints. If we go over the first 6 chapters and then do 10, 11, and 12, and then if we go through the first 6 chapters, then do 13, 14, 15, and 16, and then 17, that's already like about 10 or 11 chapters from the book in 40 days. That's basically doing more than a chapter a week. Don't know if we'll have time or not. But I did quickly go over Chapter 7, talked about the differences between themes and styles and how to work with both, looked a little more at colors. Then we went through Chapter 8, and that was on how to work with menus and preferences. And then Chapter 9, which was on fragments. All right, so again, there's a quite a good chance that I will spend a lot of time on Chapters 1, 2, 3, 4, 5, and 6, and maybe one collective period total on 7, 8, and 9. I plan on spending in class 0 time on this newsreader app, 10, 11, and 12. They do talk about how to work with threads, files, adapters, intents, services, and notifications in a very short chapter on broadcast receivers. So what I'm going to start doing right now is going through Chapters 10, 11, and 12. I'm not going to write any code. I will look at the newsreader as it's developed for Chapters 10, 11, and 12. But I will write the code, or at least do a much more intensive job of going over the code for Section 4 for the task list app. All right, I just wanted to make that clear as we get started. So, as we get into Chapter 10. Chapter 10, again, as you can see on the screen right now, how to work with threads, files, adapters, and intents. Chapter 10 starts on page 287. We have 7 applied objectives. Number 1, given a task that takes more than a few seconds to execute, create a new thread to begin executing that task right away. In other words, do you want to be able to run multiple parts of a program at one time, or do you only want to be able to run one part at a time? When that part finishes, you can start another part. Number 2, given a task that takes more than a few seconds to execute, create a new thread that executes that task after a specified delay at a specified interval. So we're talking about using timers. Number 3, after a thread finishes executing, update the UI thread. UI for user interface. Number 4, given the URL for a file that's available from the internet, write the code that downloads the file from the internet and saves it to the file system on the Android device. Number 5, given data that's stored in an array, use an adapter to display the data in a list widget and handle the events that occur on this data. Number 6, use an intent to pass data from one activity to another. And finally, number 7, use an intent to start a web browser or to dial a phone number. Those are our 7 applied objectives. We have 3 knowledge objectives. They are: explain why you should use a separate thread for any task that might slow or stop the responsiveness of the user interface thread for the Android app. In general terms, describe how an asynchronous task works. Number 3, describe the difference between an explicit intent and an implicit intent. And one of those things that kind of caught my eye is, let's talk for a second about asynchronous communication versus synchronous communication. Here's Wikipedia. All right, methods of synchronization. There are 2 ways that you can synchronize the 2 ends of communication. All right, synchronous allows 2 different signals. Asynchronous uses only 1 signal. Well, that's not a great explanation. Let's see if we can find something a little better. How do these work? How about this? The differences. Asynchronous communication does not wait around for a reply. Synchronous communication requires parties or components work simultaneously in real time. And not great either. Let's see, how about one more? Okay, here's synchronous. When I call you on the phone, I dial your number and wait for you to pick up. Then you say something, and in that moment, I listen to you. When you're finished, I send you data, or I talk to you, okay, and at the end of our communication, we get done. So, in other words, synchronous is more the way that human communication is supposed to work. So I come into a room and you're into that room. I say hello to you, I wait. You say hello to me, you wait. I tell you about my day, you wait. You tell me about your day while I wait. All right? Asynchronous communication says the difference is I write you a letter, I put it in the post office mailbox so it's sent to you. In the meantime, I don't wait for you to respond. I do other things. Then you receive the letter. You may read it while I'm still doing other things. Then you write me an answer and send it to me. All right? And the next day, I get a message from you. Okay? So the idea is, this isn't a great example, but let's assume that you are talking with somebody that you really don't care for. All right? So, after a while, you get really frustrated. And you decide that what you're going to do is, they're talking, but while they're talking, you don't want to hear it anymore. So you leave the room and you go do something. You come back a little later. They're still talking. You still don't want to hear it. You leave and do something else. This happens 2, 3, 4 times. Finally, you come back and they're done talking. So you begin talking. They may listen. They may do the same thing as you. That would be asynchronous communication. I used to tell people, listen, I don't know if it's a great example or not, but synchronous communication, again, is meant to be like human communication, the way most humans communicate. Where I say something, I stop talking, you say something while I stop talking, etc. That kind of an idea. All right? Whereas with asynchronous, it's almost the way, imagine that I'm talking to you. And while I'm talking to you, you're texting. Okay? And while I'm talking to you and you're texting, you get a phone call. And while I'm talking to you and you're texting and you get a phone call, you're on your tablet and you're playing a game. So you're doing a lot of different things while I'm talking to you. you've got a lot of, each one of those things that you're doing could be looked at as though you're doing your own thread of communication. That's what we're talking about in this chapter. Now, that might not have been a great explanation, but it's the one I'm using. All right, so this is what we work on in the chapter. We're going to create this newsreader app that downloads news items from the web and displays them so you can read them. To be able to create an app like this, we need to learn several things, including how to work with threads, how to work with files, how to work with adapters, and how to work with intents. All right, so as mentioned in Figure 10.1 on pages 288 and 289, this is the interface. When the app starts, the top items, or the top of the items activity, displays the title for the newsfeed. Below that, it displays a list of items from the newsfeed. Each item that's in there will have a date, and it will have a time. And it's done in reverse chronological order. So the newest one will be shown first. If you click on an item in the items activity, so notice we clicked here, and this is what opens up. So the app displays the items activity, which displays more detailed information about the clicked item. Now, this isn't the same thing, but imagine it was this way. Let's suppose for a second that you like a sports team. All right? I'm living in out the side of St. Louis, so let's suppose it's the St. Louis Cardinals. And although it wouldn't be in any order, yeah, we could even do that. Let's suppose that we've got all of the people who are on the St. Louis Cardinals over here. And we have them in order based on the last person to join the team. And I don't remember his name, but they had an outfielder who just had his debut like about 2 days ago. So he'd be first. And the person who's been on the team the longest, let's suppose that they've got a player who's been on the team for 15 years. He would be on the bottom. And as you click each player's, the thing for each player, you'd get a bio over here and maybe some statistics. All right, so that's the idea. Also on the bottom here, as you can see, there's a link there that said read more on the web. And if you click that, the app is going to start a default browser for the device and display that. So you could even get more. Maybe this would go to the St. Louis Cardinals homepage or something like that. So again, when the app starts, the items activity is going to display, in our case, the title of the newsfeed, followed by a list of items in the newsfeed where each item has a publication date and a title. And they're shown in reverse chronological order. Also, if the user clicks on a news item, the item activity displays more information about that item, including a link that can display the original article. So, what we see here, this is a URL for what's called RSS, Rich Site Summary. So this is the RSS for the feed that's used by the newsreader app. So you can see that we're going out to Yahoo and we're searching for something. All right? This could be changed. So for instance, if what we wanted to research was, let's say that you've got an interest in our ongoing conflict with North Korea. You could do something like that. But in our case, the RSS feed that's returned by the URL, it's actually more complex than the XML that's shown in the figure. All right? And as you've already seen, the first things that are going to come in here and show are going to be the title and the publication date. And after those elements, we're going to see another series of elements, description, etc. So an RSS feed can be used to publish frequently updated works. Now, sometimes people get confused over what RSS is. Give you my own little take on it. Imagine, one of the most terrible times of all our lives was when 9/11 took place. Okay? And at that time, there were things happening. One of the towers was crashed into. People were going crazy, literally. Some people had to jump off of buildings, and people were wondering about loved ones, etc. So you could have brought for example, CNN's RSS feed, and it would have given you descriptions and updates on, a minute-by-minute basis, basically. All right? So since RSS uses a standardized XML file format, the feed can be published once and viewed by many different apps, which makes sense. All right, let's talk a little bit about threads. Again, my goal here is to just give you some information, bring you up to speed a little bit on this stuff, but I'm not an expert on it. I'm way far from it. But our newsread app reads data from the internet. It writes that data to a file, and then it reads data from that file. Typically, when you do something like that in an Android app, you should perform tasks, each task like this, in its own thread. So what you're meant to see on this picture here is a thread is a single flow of execution within a program or through an app. By and large, a thread is designed to complete a single task. By default, an Android app uses a single thread called a UI or user interface thread. That thread that it uses displays the interface and listens for different events to occur. This is what we've done so far. The user interface for the app should always be responsive to the user. For example, when you download data from the internet, that may take several seconds, depending on the amount of data that you're downloading, the complexity of it, the speed of your connection, etc. You really shouldn't perform this type of processing on a UI thread. Rather, you should create a second thread. All right, in just the same way, let's suppose that I'm working at a job. And let's say that I'm a supervisor. And someone comes in and they're looking for somebody. So they come in, and let's say that I'm literally supervising thousands of people on some kind of an actual site. And I don't mean a website, but I mean an actual site where I've got people working. Let's say that I'm a landscaper, and we're building a neighborhood, and we've got thousands of people. And someone comes in and they're looking for John Smith. All right? I shouldn't have to say, okay, everyone stop working. We're going to stop working until we find John Smith. Rather, we keep working, and then I might send a person out or several people out, one to each part of the work site, looking for John Smith. All right? I don't want to perform it on my main thing. I'm creating a second, third, fourth, whatever thread. Okay? So if you want to perform something like a file I/O operation, like reading or writing a file, honestly, you should do that processing in a separate thread. The main reason for doing that is I/O or input-output operations are literally thousands of times slower than CPU operations. So this first diagram that you see right here shows how an app might work if it's executed in a single thread. So the UI thread displays the user interface and sits and listens for events. When an event occurs, all right, even if it's a slow I/O thread, and since we only have a single thread, the UI thread can't listen for other events and respond to them because the original thread is running. In other words, if the user clicks on a button while the I/O operation is running, the UI thread can't respond to it. Once that I/O operation completes, then the interface becomes responsive again. Now contrast that with the bottom picture, and it shows how the app benefits from using a separate thread to perform the I/O operation. It allows two different tasks to overlap. So the UI thread can continue to listen for events while the I/O operation runs in another thread. This way, you keep the interface as responsive as possible. All right. The next thing that's discussed in here on the next pages 294 through about 297 is what's discussed here is how to work with how to execute asynchronous tasks. As they mentioned, an asynchronous task, now that you understand threads, it's a task that runs in a separate thread in the background, and it does not need to be synchronized with other threads. Again, looking at the example I gave you before. Somebody comes in looking for John Smith. If I've got people who are laying concrete, all right, and I make everybody stop until we find John Smith, now I'm losing time on the work site. But if I have people laying concrete, and somebody walks by while they're working and says, "Are any of you John Smith?" No, they can keep working. That type of an idea. Now, because Android apps often need to perform asynchronous tasks, several things at once, the Android framework includes a class, named async task, which makes it relatively easy to perform these types of tasks. The async task class handles the code that creates and manages threads. So you just need to create a class that inherits async class and override the methods. Typically, this is coded as a nested inner class of the activity class, and that's what they're showing in here. All right? So you have a class within a class. All right? So the download feed class, and we don't see it here because it's right there, but that download feed class, there's our beginning, curly, there's our ending, curly. So this download feed class that extends async task is inside of the items activity class. So this class, as you can see, begins by defining a constant for a string that contains the URL with the RSS feed. Now this download feed class extends the async class. It uses what are called generics. Generics are a Java feature that allow a class to operate on different types of objects. So in other words, in here, this will allow you to work on different types of objects. All right? Within this download feed class, there is something in here that does a do in background. All right, right here. This contains the code that runs in a background thread. So again, an asynchronous task is one that runs in a separate thread in the background and does not need to be synchronized with other threads. It's common to use a nested inner class to create an asynchronous thread. Within that class, you can access the context for the activity by coding the name of the outer class, a period, and the this keyword. When you nest one class within another, like we're doing here, the inner class automatically has access, all right, and can access the object for the outer class by coding the name of the outer class and a period, okay, and the this keyword. So we can come in here, and in here, if we want to, need to, we can use items activity dot whatever. There's, dot this right here. Now, if we take a look, and this is taken from page 297 in figure 10-5. So this example declares a download feed class that extends the async class. You can see that right here. We've got several examples. All right, the class accepts one or more string parameters, uses integer values to update the progress of the thread, and returns a string. The second example accepts a URL object, doesn't update the progress of the thread, and returns a string. The third example shows you can use the void keyword with all the generic types. Notice void is in uppercase. This can make sense when the class for the async task works with instance variables. The fourth example that's there declares a read feed class that extends an async class. The figure also shows the four methods that you can override right here. Of these four methods, the code within the do in background method executes in a background thread. So you should put any network code or any IO code in there. The other three methods that you see, the pre-execute, the on-progress update, and the on-post execute, they all execute in the UI thread. So you can use them to update. All right? You can use them to update the user interface. So this async class provides a fairly intuitive way, at least, to perform a background task and publish results on the UI thread. Now, this has to work with timing. And when you work with timing, you have to understand the difference between timers and interval timers. All right, and the example that I always give for this, and it's not a great example, but back in the olden days, and they still exist, people would often have the old alarm clock that they would wind up. All right, they'd set their alarm for 6 o'clock. At 6 o'clock, it would go off. You'd hit the button on the top, and it would stop. That's a one-time timer. On the other hand, today, and I know I've done this, and probably most of you have as well, the alarm clock goes off at 6, and you're really tired. You're still really tired. So instead of getting up, you hit the snooze button. Then 9 or 10 minutes later, it goes off again. You hit snooze again. Then 9 or 10 minutes later, it goes off again. That's a timed interval. So it's a single time versus a timed interval. Now, Android apps sometimes need to start a separate thread to execute timed tasks, something that executes after a specified delay. For example, with this newsreader app that we're writing, you might want to check updates every hour or every half hour or every 5 minutes, or if it's a major enough story, every minute. If you had a stopwatch app, you might want to be able to check every second. So to do that kind of stuff, you use the timer class and the timer task class. Now the timer class, the second one that you see here, has timer, and notice it says is daemon. Well, a daemon thread is a thread that ends when the app ends. So the timer with the is daemon creates a timer object and specifies whether the thread is a daemon thread that ends when the app ends or not. Does it keep running, for example? Schedule, which executes the specified timer task once after some kind of a delay in milliseconds. Schedule task delay interval, which executes the task repeatedly after a certain number of intervals. So this first one is more like the old-fashioned alarm clock. This is like the thing with the snooze. Cancel a timer. Well, if I've got my alarm set for 6 o'clock and I wake up and it's 5 to 6, I might just turn the alarm clock off, and that would be the cancel. We've also got timer task, which creates a new timer task object, and run, which is an abstract method of the timer task class. So you use timer task and timer classes to create threads that execute tasks after a specified delay or at a specified interval. When you do this, if you create a time task that runs in its own thread in the background, all right, then as the background thread runs, you need a way to update the UI thread. So you can use the post method that's available from the view object to do this. And the code shows you right here. This is taken from the figure that's on page 301. So you can use a post method. All right, you can use a post method as is shown right here of a view object to execute any runnable object on a UI thread. All right. So the next part, starting on page 302, is how to work with files. Even though I'm not going over this in a lot of depth and breadth of coverage, I still want to break this up into as many lectures per chapter as we need, so I'm going to stop right here.